When we talk about a derivative, we are talking about a rate of change. When I talk about a rate of change with a constant, that rate of change will be 0 because the value is constant. It is not changing. So whenever we look at all of these problems we have listed, when we do the derivative of those, our answer should be 0 because 9 does not have a rate of change. It is always 9. Just like the derivative of 0 is still 0, and the derivative of -8 would still be 0. Again, just because we have a negative sign or anything else of that nature, we're still going to have our derivative value to be 0. Now for part D, notice it kind of looks like that you're going to have some kind of value here, but a times pi cubed is still just a number. So a is still also a number. So when I do this derivative here, I'm still going to get 0. The next type of derivative we will look at is the derivative of a single variable. If we are taking the derivative of x, that is always 1. And again, it's not going to change as long as we're having just one particular variable. That derivative should be 1. So the derivative of x is 1. The derivative of f of x that equals x is still 1. And notice here in part C we've changed the sign, but the derivative of t is still 1. The next type of derivative we'll talk about in this video is called the power rule. And with the power rule, notice we're taking the derivative of something that is not a constant, and it is not just a single variable. So looking at part A, when we do the derivative, what we do is deal with the exponent, and we will take our exponent and move it down to the front, and then we subtract 1. So y prime will look like, and do make sure you do y prime, not just y, it's going to be 2 times x to the first, or just 2x. Okay, let's look at part B. And again, we are still doing our power rule. So we are moving our exponent down to the front. So we're going to write f prime equals, exponent moves to the front, and then we subtract 1 from that exponent. So part B is going to be 6x to the 5th. Continuing this with part C, again, same process, and we are going to say s prime at t equals, we are moving our 30 down to the front, so I have 30x to the 29th. Now part D is a little different because we don't have an exponent written, so we do need to change this so the square root of x would be the same thing as x to the 1/2 power. And again, we still work through the same process, so we will have y prime equals, again, move your exponent down to the front, so we have 1/2 x to the 1/2 minus 1. Now we do have to simplify 1/2 minus 1. That's going to give us -1/2, but we will leave our answer like that. We're going to have y prime equals 1/2 x to the -1/2. And it's okay to leave your exponent in that form for right now. Continuing on with our problems, E. Now E is not an exponent form for our power rule, so we will have to flip our x value over, and the exponent that allows us to do that is -1. So we do have to rewrite that, and then we're going to go to y prime equals, and again we would move our -1 down, but then our exponent is going to be to the -1 minus 1. So that does change it a bit. So we have y prime equals -x to the -2. And it's going to be okay to leave your exponent like that for right now. Okay, moving on to the next one. Same process here with f. We're going to have to rewrite f of x to be x to the -3. Now we're going to do our derivative. So we'll have f prime at x equals -3x to the -4. Again, it's -3 minus 1, so that's where -4 is coming from, and you are finished with that one. And now for part G, Again, we do need to rewrite this. So s at t is going to be, we need to flip that over, so it's going to be negative, and the exponent that means cube root would be 1/3. And so s prime at t is going to be negative 1/3. Again, we're moving our exponent down, and then 1/3 minus 1 is going to be negative 4/3. And it's okay to leave your exponent just like that. All right, now for part H. Part H, again, we do need to rewrite this. So this is going to be x to the negative 3/4. So y prime is going to be negative 3/4 x to the, and again we're subtracting 1, so that's going to be negative 7/4. And we are welcome to leave it just like that. Okay, now for this next part, we're going to mix up quite a bit of stuff here. We do have a variable that's going to be in to multiply to a constant. So again, starting out with a, we do need to rewrite this. And so we would have 2 is still in the numerator, but we're going to flip that x over. So y prime is going to be negative 4x, and then if we subtract 1 to the negative 3. Okay, same process over here. Now, one way to think about for b when you have a fraction is to rewrite this to be 4/3 and then x to the third. That usually helps out with the derivatives. And again, f prime, we are going to multiply this 3 down to the front. And so notice what we have. I'm going to write it out, but in the future you don't have to by any means. So notice that 3 is going to go to the front and multiply to the 4/3. And then don't forget to subtract 1 from your exponent. And now those 3's will cancel. So f prime is really equal to 4x squared. For part C, again, some of the same stuff. We are multiplying with our exponent down to the front. There's no rewriting involved. So 5 times the negative that's already there would be negative 5t. And if we subtract 1 from our exponent, we get to the positive 4. Not negative 4. Well, here, I'll just change it right here. All right, so now for part D, still the same process. Now we do have to rewrite here. So I'm going to go ahead and rewrite this to be 4x to the positive 1/2. And so when I have y prime, I'm going to have that 1/2 times 4, that's going to be 2, x to the 1/2 minus 1, which is negative 1/2. And you are finished. Moving on to E. Same idea, I would separate this, and so you're going to get negative 5/3. I would write that as a fraction, and then this x, I'm going to move it to the top and be x to the negative third. So now when I will write my y prime, again I'm multiplying that 3 down to the front, so I really have negative 3 times negative 5/3, and then x to the negative 3 minus 1, which is negative 4. And then to clear up the coefficient, it looks like I'm going to have a positive 5 and then x to the negative 4. Okay, so let's look at part F. Now part F, we've got all of that inside the parentheses raised to the third. I would go ahead here and let's find out what that value is going to be. So we have f of x equals 5 over, well, 3 to the third is 27, and then we have x to the third. And then I would separate this and say, well, that's really 5 over 27 times x to the negative 3. Now we're ready to do our derivative, and we would multiply that negative 3 down to the front times 5 over 27 x to the negative 4. And then we can simplify our fraction. So 3 cancels into 27 9 times. So our final derivative here is going to be negative 5 over 9 x to the negative 4. And again, you can leave that x to the negative 4. All right, part G. again, more of the same. We do need to rewrite this, so that's going to be 4t to the negative 1/2. And so s prime at t, I'm going to multiply that negative 1/2 down to the front. So that's going to leave me a negative 2 when I multiply it to the 4. T to the negative, and if I subtract 1, I'm going to get negative 3/2. Okay, for the next one, part H, again, a lot of rewriting here. The first part, that is really going to be the exponent of 5/3. And then if we move it up to the top, it's going to be x to the negative 5/3. Now we're ready to find y prime. So I'm going to multiply negative 5/3 times negative 12. And then x, and if I subtract 1 there, I'm going to get negative 8/3. And we do need to simplify here. 3 will cancel into 12, leaving 4. Our negatives do cancel. So y prime is equal to 20 x raised to the negative 8/3. All right, now we're going to look at our sum and difference rules, which the rules are not any different than what you've already looked like. You're just doing a lot of adding and subtracting. So looking at this first part, so we have y prime equals, and we just do the derivative of each individual part. So the derivative of x squared, we're going to multiply that 2 down to the front, so that's going to be 2x to the first, plus, and if we do the derivative of 5x, 1 times 5 is still 5. And if we subtract our exponents, then we see that the x's disappear, and the derivative of negative 3 is just 0. So this portion right here would be our final answer. Looking at part B. Part B, we would go through the same process. So we can go ahead and say f prime equals, this first one would be 4x to the third minus, and again multiply the 3 down, so that's going to be 9/2 x squared, plus multiply the 2, so that's 4x, plus the derivative of just the x is 1, and derivative of negative 6 is 0.